Hello guys, welcome to this channel. In today's video, we're going to learn how to derive the units of derived quantities. In my previous video, we learned how to derive the quantities of derive the dimensions of derived quantities. But in this video, we're going to learn how to derive the units of those derived quantities. If you haven't seen my video on that, just go to the channel and search for how to derive dimensions of derived quantities, and you have that popping right up for you. So in this place we have a question: derive the units of the following quantities. Like I told you in that video, if you have watched the other video on derived quantities, I said you always need to know the formula for each of these quantities to be able to find the unit or even the dimensions of those quantities. Now, first thing you need to know is that mass is a fundamental physical quantity whose dimension is represented as m. You have time, dimension for that is t, and then you have length. The dimension for that is L. So these are the three most basic fundamental quantities which have their dimensions like this. Now, these are only the dimensions for these quantities. But the units for these quantities now are: for mass, you have kilogram. So this is the SI unit, is called the International System of Units that has been introduced by the International Society of Science. So you have kilogram as the SI unit for mass, and the SI unit for time is seconds, and the SI unit for length is meters. So that's that. Now you need to know these two parts to be able to derive any unit, to be able to derive the units or dimensions of any derived quantity at all that is given to you. So in this case, we have velocity, we have force, and we have momentum, and we are asked to find the units of each of these quantities. So the first I'll go for will be velocity. So that's velocity there. So now you need to get the formula first. So velocity, the formula for velocity is distance, or you could say displacement, over time taken. Since velocity is a vector quantity, it has both magnitude and direction. We now are going to represent it with the relation of displacement rather than using distance, because distance is just a scalar quantity. It doesn't have a direction actually, it just has magnitude. But displacement has both direction and magnitude. So the formula for velocity is actually displacement over time. But displacement is the same thing as the distance, whose dimension is L. But we are not talking about dimensions in this case, we're talking about the units in this case. So the unit for displacement or length or distance is meters. So we put our m there, and then the units for time is s. So that's that for that. So now, how many s do we have in this place? We have just one s. What if I don't want to represent the unit as m over s? What if I want to remove this fractional sign which you see here? What am I going to do? That is, I want to bring this s to be on the same line with m. I'll put my ms there, and then I'll just introduce negative in front of the 1. Because we have 1 of the s, that means s is raised to the power of 1. So if I want to bring it to be in the same line with m, then I'd introduce a negative in front of that according to the laws of indices. So this is now the unit for velocity. So the second case we have there is momentum. So the formula for momentum is mass times velocity. So when you see mv, you're talking about the momentum of whichever object in question. So the unit for mass has been given to be in kilograms, and then the unit for velocity has been given to be meter per second. So if you multiply all these together, that should give you kgms raised to the power of -1. So this becomes the unit for momentum, as you can see here. And the last case we have here is the unit for the derived quantity, force. Now force, the formula for force is mass of that object multiplied by the acceleration due to gravity. So now, the unit for mass, like you have seen here, is the kilogram, which is represented here. And then for acceleration, unless you know the formula for acceleration, you may not be able to really get out the dimensions that are involved in acceleration. So if you talk about acceleration, we are talking about velocity over time. So if you have not watched my previous video on how to derive dimensions of derived quantities, then that is the video which contains this part. So we have kilogram multiplied by velocity. Now the units for velocity is meter per second. So I just write that meter per second there. And then over time, the unit for time is second, so I put that there. So now this becomes kg. So this could be called kg over 1, just to make it as fractions. And in multiplication of fractions, the numerator always multiplies with the numerator, and the denominator does the same with the denominator. So we have just kg multiplied by ms raised to the power of -1. Then you have s. Now there is something very important here. If you want to make this s to come to the same line as this one's up, how would you do that? That is, if you want to remove this fractional sign in this place, how would you make that? How would you bring that about? The first thing you need to know is, remember when we were removing this fractional sign from here to bring this s to this front, we introduced a minus in front of the power of x, which in this case was 1. So just to introduce minus according to the laws of indices, it was -1. Now if we want to do this, how would we do that? That means we can bring back this s raised to the power of -1 down. So that means we could have kg m over s. Therefore that raised to the power of negative removes away. Then you have s times s. So this now becomes s squared. So if I were to bring this s squared to this side, we would have raised to the power of -2. So this becomes the SI unit for force. But because the most important person that worked on force was Isaac Newton, actually the SI unit for force now is in newtons, just in honor of Isaac Newton. So we have the N as the sign for force, but actually the SI unit, or the main units from the derived quantities from the dimensions, is kgm s raised to the power of -2.